of the Gaussian elimination, and there were a couple of review problems that I assigned to kind of give you an idea or summary of Gaussian elimination, and that was on page 500 and page 561. So I thought I would go over number 41 and 86 from page 500 so that you could kind of see how to work through a non-square system and then how to set up the application problem for number 86. If you find that you have other questions, please don't hesitate to email me or send me a text through Remind. I also have a Zoom session set up for Monday at 10 a.m., so that's a great way for you to get any questions answered that you may have, and then you get to see my smiling face for a little bit as well. So, as I said, I want to look at number 41. That was the non-square system. And we have 2x minus 3y plus z equals negative 2. And then negative 4x plus 9y equals 7. So in this case, we have a non-square system, which means 3 variables, only 2 equations. We will not have a unique solution. Sorry, I can't speak. I would say let's try and get rid of these x's. So if we try and eliminate the x from the second equation, we could multiply the first one by 2. So now we have a 4x minus 6y plus 2z equals negative 4. And x's, that's usually the easiest thing to eliminate, keeping that first equation the same, but eliminating the second equation or trying to rewrite the second equation. So when we cancel out the 4y, or 4x's, we end up with 3y, 2z, and then that's equal to 3. So a non-square system doesn't have an actual solution like 1, 2, 3. At this point, there's no more elimination you can do. So non-square systems are actually less work, but we have to write the answer with a certain pattern. So we would then say let z equals a. That's our first statement. So you've used elimination once. You have this 3y, 2z equals 3. Generally, we start with that last variable and let that be a. So now z is a. We are going to go into the second, or that new equation that we created, 3y plus 2, z is now a, and then that's equal to 3. So going into the new equation, replacing z with a. And then when we divide by 3, we end up with negative 2/3 a, and then plus 1. I'm just simplifying that. So now z is y is negative 2/3 a plus 1. So there's my second variable. Now we need the x variable. And if we look at this second equation right here, notice that it's just x and y. So it's probably really easy to solve for x when only one other variable is in the equation. So I'm going to use that equation. We have a negative 4x, a 9. We just found y to be negative 2/3 a plus 1, and then that's equal to 7. So using this equation, I only have to worry about just plugging in for the y and not the z. Distributing, this works out kind of nice because when we multiply by 9, we end up with negative 6a plus 9 equals 7. And then that gives us 6a minus 2. So divide by the negative 4. And x is now negative 3/2a plus a half. So writing our solution as an ordered triple. Negative 3/2a plus a half. Negative 2/3a plus 1, and then a. So now I have x, y, z. So again, using Gaussian elimination, only one time eliminating the x variable. After you get that statement, which is this statement right here, then we say let's let z equal a. so that we can get an expression for y. We take that expression for y so that we can find an expression for x. So the other question, as I said, I wanted to go over was 86, which was the word problem. And in this word problem, we are a small corporation, and we're borrowing $8,000 or $800,000. So we borrow $800,000. And we're borrowing that from 3 different types of lines of credit. So the first line of credit would be the amount at 8% or 0.08, the money we borrow. The second one is the money we borrow at 9%. And then the third one would be the money we borrow at 10% or 0.10. It also says that we have to pay the annual interest from those rates, and that's extra money that we pay on top of the $800,000, $67,000, and that's a year. So every year we have more interest that we have to pay. So trying to come up with an equation, we know we're borrowing $800,000 in 3 different amounts that have to add to be $800,000. So those 3 amounts are x, y, and z. They must add to be $800,000. We know that we have to pay interest. And the way we pay interest, or the reason we pay interest, is because we have these rates. Those rates are 8%, 9%, and 10%. Well, that has to be equal to the interest that we have to pay. The last equation, the last little piece of information says the amount borrowed at 8%, so amount borrowed at 8% is x, was means equals 5 times the amount borrowed at 10%. Well, that makes sense because I'd want to borrow more at a lower interest than I would at a higher interest. So again, the amount at 8% was means equals, borrowed at 10% was 5 times more. So if we set that into the form of my others, where the variables are on the one side and the number is on the other, we would have an x minus a 5z, and then that equals 0. So those are our 3 equations. You can use matrices if you want for this. You will be told when you can use matrices on the quiz. We have a 1, a 0, and a -5. Solving for x, y, z, and then that's equal to the 800,000, the 67,000, and then the 0. And you should end up with the amount for x being 625,000, the amount for y being 50,000, and then the amount for z being 125,000. So hopefully that helps clarify anything. Again, if you find that you have other questions, there's a Zoom session at 10 o'clock on Monday, and feel free to join and ask any other questions that you have about Gaussian elimination. I'm going to post a quiz today, and that quiz is not due until the end of the day on Wednesday. So that's why Monday's session, if you get stuck somewhere, if you have other questions, then you can feel free to ask them then. Have a great day.